Oh, hi, everybody. It's time. We're back for another week of the Nerd Log. We have one guest this week because one is all we need. First, let's introduce my wonderful co-host. I don't have Twitch open yet, so I don't know if I'm down, left, right, but they're there. Daniel, wherever you are, speak to me. Speak to me.
Hello. Hi. How's it going? My name is Daniel, and I am part of the Relicans, and I'm super excited to join the Nerd Log today. Super
Thank you
excited.
so much. This is your first time co-hosting, is that right? I follow you so close. I'm like such a stalker of your stuff. I feel like we know each other, Daniel.
I know, right? Yeah, it's my first time, and it feels amazing. And Mika, you are amazing.
Thank you so much for coming out.
Big fan.
The Nerd Log, for those of you who just saw a Twitch notification and clicked it, which please, if you did that, have better boundaries about your work and your home life. Like, don't just click on every Twitch notification. The Nerd Log is our weekly update on what's changed at New Relic, what new features we're doing. But often, because we're not making Overwatch here, it's a little more focused on like, what does this mean for you, and how does this feature get used? And our one amazing guest is Ashton. Now I have the Twitch open, so I know it's down below me. Ashton, introduce yourself and tell the people what you do for New Relic.
Oh yeah, so my name's Ashton, and I work on the Query Experience team, which is the team that works on NRQL and the execution of that, and all the systems that surround querying your data.
Nice, awesome. So, this segment today, if you don't have your data coming into New Relic yet, if you're thinking about using New Relic, I only kind of want to make like a little bit of a caveat here, which is like, we're going to show you how to get custom data with New Relic. Now, go and watch some of our other segments to see how we do incredible stuff right out of the box. Cool, pretty dashboards. I mean, now we can like scan your traffic with AI or your metrics with AI, tell you when you have anomalies and automatically alert you. Like, cool stuff right out of the box. And I don't want anybody to come away thinking like, oh my God, I have to write some kind of SQL-like, queries to be able to see any data on New Relic. But this is definitely, once you have data reporting, especially once you have kind of production data, you have hundreds or thousands of entries in the metrics table. It's time to go on and get a little more advanced and get exactly the data you want. That's what we're talking about. So tell us what we use this term NRQL all the time, but I do usually try to say NRQL. But tell us about NRQL or NRQL.
Yeah, so NRQL is, as you said, a SQL-like language. So if you've seen SQL, this is similar to that, but I would not take everything you've learned from SQL to this, because there's a lot. It's a different language and it has its own quirks and features. But I will say this is not just for custom data. There is a lot of stuff that comes out of the box with the agent that this will work on.
So to clarify again, or hopefully. Stop me before I clarify again. But this is about you install the New Relic agent, you get this data, and then you can use this to make a custom view of that data. Yeah, it's not necessarily that you're sending something custom. Yeah, this is a great way to slice and dice data that's already getting sent by an infrastructure agent or application agent. Yeah, we'll get into it. But yeah, it's not like you have to go and add a bunch of stuff to your application code to get this information.
Yeah, and I also want to mention that New Relic also has a lot of things that come out of the box. So a lot of these graphs and visualizations, you can just go automatically pre-populated. This is what we want to extend what's already there to fit your unique use case.
Yeah, this is exactly right. It's like was trying to say, maybe I didn't really get across. It's like, just that, if you have a question like, what's my slowest web request that comes in every day to my site? Like you have a chart of that. We give you that. That just comes out of the box. But this is about go a little deeper. You have a question. I mean, let's invent one now, right? You say, well, here's a story I've told before, but I'll tell it again. It's like, I worked with this e-learning company, and we had a problem where you could set up a virtual classroom in our system. Most people, 5 kids, 10 kids, 30 kids, right? And then we had a couple school districts that put everybody at a school in one class. So the class was 500, 800. And this was an old school company. The system did not handle that like 10x request well at all. So they had a really bad user experience. And the thing was that in that case, it was like all of our charts, all of our New Relic charts looked great, right? because our average performance was fine. Now, this was years and years ago, and actually New Relic has gotten quite a bit better at showing like, hey, you have outliers that have really poor performance. But a question like, show me the traffic by school district, show me the school district that has the slowest performance. Like that's something that, obviously we're not showing you out of the box as a chart. It's something you'd want to set up a custom query like this to get that view.
Yep. So yeah, so let's jump in. So right now I'm on the landing page for NR1, our recent adaptation of the UI. So if you jump up to query your data, and you may start over here in the data explorer, just hop over to the query builder, and this will land you in a query bar, allows you to just type in some NRQL. So to start off, let's check out the transaction event. So this is something that most of the agents will send by default. These are kind of like if you get an API request, it'll likely have a transaction that reflects that API request.
Yeah.
So if we do something like select star, we can kind of take a look at these, and you'll see that you get a whole bunch of things that come along this. And we're going to be taking a look at duration. So duration is the length that transaction took to execute.
Yeah.
So
if we want to think about this as like, you maybe have your front end sending back a request and getting a response. It is the time that the application you're monitoring handled that response. So there's caching or something after it that's probably not included, but this is the time that your code and the libraries that you've implemented, they're handling that request.
Right. So if we do something like average duration, so select star obviously just gives you everything. Average duration will then give you a single number that says what's the average duration in seconds. So this is going to be 800 milliseconds.
Zoom in and enhance by like 1 or 2 zoom steps. Let's see if we can get the query at the top to display a little bit bigger.
Yeah, let's see. I don't know if my Windows keyboard is working with Zoom correctly. Let's see if I can get the command to run.
Oh, the zoom is like just not activating.
Yeah, the hotkey is not.
If you hit that hamburger or the menu at the very top right, you can hit zoom and hit the plus on the zoom for the browser. Yeah, there we go.
Yeah, I think I got it.
Yeah. One more. Oh yeah, now I'm feeling it. Yeah. Again, this will cause a little bit of page cropping, right? Because from the user view, this is quite zoomed in, but this is perfect for our stream. I love it.
Cool. Yeah, we may run into some queries that go a few lines, but we'll see what happens. So yeah, so this is showing average duration here.
Nice.
But usually people as a singular value, this is super useful. So we can expand on this and do time series, which is what you'll usually see in default widgets, which will give you a chart of that value through time, given say like a 1 hour default window. So this is starting from now till 1 hour ago. What is the average duration through time? So
love it. So
one of the things that
I want to pause because we have a great question in here, which is a little bit left field of this, but can you use this trigger to create custom reports? Now, reports I think have a specific meaning within the New Relic context of like what is a report. But for sure, if you want like an alert that says, hey, this query went over a certain value, yeah, you can absolutely use NRQL to create alerts. And that's mostly where I interact with it, is that when I'm working on the serverless side, things are kind of less standardized than they are in the application monitoring. Those are some old style application monitoring. So yeah, you can absolutely you can put in any arbitrary query and say, do this. So an example, the one that I always do in GSH, it looks like you got it, is like, on serverless, we measure available memory, or we measure the memory allocation and the memory used. And you could set an alert to just say, hey, alert me when memory used goes above a fixed number. But I will make a custom NRQL query that says, alert me when the memory percentage used gets above a certain point. All right, that's that. I'm sorry, go ahead.
Oh, I'm saying, so I recently integrated New Relic into a serverless app as well. And I actually integrated it with CloudWatch. So if like there's a lot of traffic to my hitting my serverless endpoint, I get alerted through New Relic. And I have a custom NRQL query that I added an alert to, which is really, really seamless. So I think that's a really good use case for NRQL queries, is creating custom alerts.
Yeah. All right. But yeah, so we look at this as a time series now. So back to our demo. Let's dig in.
Yeah. So maybe average isn't too useful for you. So because average does smooth it out quite a bit. So we can do something like percentile. And let's get like the 50th, 95th, and 99th percentile. So this will give you, what's the distribution of this duration to see what the upper bound is. And you'll see the upper bound is significantly higher than the average down here at the 50th percentile. These are taking, multiple seconds to respond. But the other thing is, so this chart isn't extremely high resolution by default. And the reason that is because of speed. If you like your query, generally we tend towards defaulting the query to run quickly to get your answer back quickly. But say I would like a high resolution chart.
Yeah.
So people who have used NRQL before would know that this time series does take a second parameter here. So if you did like time series 1 minute, this would specifically mean that each one of these data points you're getting here are 1 minute's worth of data. So in an hour-long query, this is 60 data points.
Yep.
One
we
data
try
point
to,
per minute.
Since we do a lot of graphing out of the box, we try to make these have not too many points on them, right? We just try to show you, a nice, 12 segments or something, and then tie it together as a line. But there are some times, especially if you're looking at a longer time period, it's like, well, that smooths it too much, right? We're not showing, oh my gosh, there's this huge drop off in this minute, and then it comes back a minute later.
Yeah, and also, so from that, a lot of people think that, okay, say I want to take this chart and make it have more data points. I want to see the data more granularly than it is shown right here. One of the other syntaxes you can have is time series max. So like I said, this chart right now has 60 data points, 1 per minute. Time series max will scope that into having our maximum number of buckets possible, which is 366. So it's going to be substantially higher resolution than this. But you'll find that comes with issues. So if we run this, it's very spiky. So you'll see that the volatility of the data has gone up. So say you wanted the chart to look like it did before, but you want the resolution to be higher. So in previous features or in previous iterations in NRQL, this was not possible. If you wanted to get high resolution data, you had to also change the semantics of what you're asking for. Because each one of these buckets now has 1/360th of the data points of the total values. So a new thing has been added to NRQL called slide by. And slide by basically...
While you're showing slide by, sorry, Ashton,
Go ahead.
I said, I warned you. I said, I'm an interrupter. It's a curse. But the big thing to think about when you try to, zoom in on time series, right, is that reporting doesn't happen continuously, right? Like this is not like a sensor that's wired to the side of the Mars Discovery rover, right? That's basically any short time window you can keep getting data that is, at that resolution, right? We're getting stuff usually as HTTP requests that come into the New Relic endpoints, right? So if you zoom in too far and you do no averaging, right, you get this thing where, it may just be that a bunch of your data is getting, yes, it is time coded, right? But you will get this skewy data. And like the classic that I would always see is people would zoom way in and they would say, oh, in the last minute, stuff just fell off a cliff. And New Relic has done some engineering improvements to make this show up less often, but it's like, yeah, because we don't have data yet for the very last 8 seconds of time, right? So of course we don't yet have that reported data. So you can occasionally get yourself in that situation. Anyway, yeah, let's smooth this out a little bit, but keep that resolution.
Yeah, so yeah, one of the things is in this chart, you can see there's a pretty strong signal here. But when we zoomed into time series max, this signal was drowned out by the fact that the resolution, the buckets got so small, it became much less clear that this spike was here. Maybe we want to see this spike in higher resolution than, the 3 data points that it's currently used by. So what we can do is do time series 1 minute slide by, let's say 30 seconds. So what is this saying? So right now, in this chart, we have 1 minute buckets that are 1 minute apart. So they're exactly adjacent to each other in 1 minute intervals. That is not what this is doing. What this is doing is saying, I want 1 minute buckets that are overlapping by 30 seconds. So each bucket is shifting by 30 seconds, which means there's overlap. And what this allows you to do is keep the semantics of how many data points are in each bucket, but allow you to have more of them. So because these are sliding by 30 seconds, we're going to be going from 60 data points to 120 without changing the size of the bucket, so how many data points are in each one. So if we run this, we'll see now, we still see that spike, but now you can see there's twice as many data points.
Ashton, we're cropping off the very bottom of our view. Thank you so much. Got it.
Cool. So yeah, so you can see there's a lot more data points. So you can use the same semantics as you did before. What if we want all 366? Well, you can use max here as well and run that. And now we are getting many more data points, but we still get a strong signal because we're using 1 minute buckets. So you can see this looks significantly different than if we run time series max as this semantics.
Oh,
so you can see that that signal's not nearly as visible here.
Yeah, this looks like digital voltage control where you can't tell that you have a sudden spike. It looks like digital voltage control. You all know digital voltage control, right? When you hook up a MacBook charger to an oscilloscope and you zoom in. And anyway, sorry, looks like
bringing me back to my EE days in college.
Whoops, got off topic. Sorry about that. But yeah, a whole little cluster of spikes that happen to be very slightly close together don't look like a spike, right? They just look like a cloud sort of, And so the fact that like, hey, most users were having, 99th percentile, the highest, response time users started having a really bad experience. It just really just gets it's hidden.
It's much more obvious to see that we had a period where the 99th percentile was 10 seconds for a good 3 minutes.
Yeah. So if you have some people who are saying, hey, the sales team says that the system ran really slowly for them. Oh, and yet you had no user reports, you had no complaints on Twitter, right? You had no call outs. No one was sharing those iPhone, screen captures of you loading slowly. You wouldn't miss it if you didn't have this view. I really like that. Just to be frank, we're so lucky that we have a nice data set that like looks good with that.
Yeah, so, and one thing to call out with this that's not super clear when you immediately approach the syntax is when you're using slide by, you cannot use max here.
Okay.
You'll see it's not happy with this. And if you think about it, it kind of makes sense. Like now this is specifically talking about the bucket width. It's not talking about how many buckets there are. What is the max width? That doesn't, like semantically, doesn't even make sense. Is the max width the width of the entire query? I don't know. So, yeah, when you're using the syntax, you have to explicitly say what the size of the time series needs to be. And then you can use the max out here to say how many buckets you want. Nice. Another thing that's worth calling out is that there is a limit to this. So if you think about it, remember the right now they're overlapping a little bit. There is a maximum for how much overlap can happen. And you'll see that error happen if you try to do too much overlap. So if I did, say, time series 59 minutes. So now this is a bucket that's basically the length of the query.
Yeah.
And it's going to be shifting very ever so slightly throughout this entire thing. Yeah. So you're going to result in a query that overlaps like hundreds of buckets on top of each other. And this won't work. You'll get an error message if you see this. Just reduce the size of the bucket if you get an error message from that. And you should find a spot that works out.
Yeah. That's like doing the reverb turned up too far. Just get like
so that's
drone. Yeah.
That's the TLDR on the slide by feature.
I like it.
So let's jump into the next one. So another thing that comes up pretty commonly is trying to filter down what you're looking at.
Yeah.
So if we do say from transaction error, which is another thing that comes along with default agents. This is basically saying this is a transaction, but it failed. And then we grab some data and put it in this event. So if we do select star with this, with it being zoomed in, it's kind of hard to tell what's going on in here.
Oh yeah,
But
sorry.
you can see we grab.
Like, you
So
know,
this is like
we do our best to fit all the data on screen. So if you do zoom 150%, surprise, surprise, it's a little more scrolling than we might like.
Yeah, so you can see like, error class, illegal argument. This is Java stuff. But if we pick on one particularly, let's do something like host. So you'll see we have a whole bunch of host names in here. So what if I want to say only look at the host names that are IP addresses? Where I could do something with a like clause here. So if I did host like IP%. So what this is a feature that already exists in NRQL. This is a wildcarding syntax. So this is basically saying I want to look at the strings that start with IP and then are followed by anything.
Yeah.
And this allows you to basically say, given all these events, right now you can see there's a whole bunch of events in here that aren't IP addresses. These hosts are various GUIDs, I guess. If we run this, we can see, oh, there actually is a whole bunch of hosts in here that start with IP address or are an IP address that start with IP. But what if I want to look, for whatever reason, saying this is a bit arbitrary for the example, what if I want to look at a specific IP range of hosts? With like, you can't really do that because this is wildcarding, right? So this is saying anything follows here. You could do something like, 10, looks like they all have 217. And then I could list out all of the versions of this that I want. So I could do hostname this or hostname, 8 and do an exhaustive list of these. But that would be a huge overhead for the writer of the NRQL to come up with this exhaustive list of things you want to be looking at. So there is a new feature that uses regexes to allow you to narrow things down a little easier.
Now, is all the regex stuff is all in beta?
No, so this one is not.
Oh, okay.
This one is
fully try it out today. Oh, okay. All right.
Absolutely.
So I promise folks, when we get to stuff that is in beta, we will flash a big red warning on the sign so that you don't come at me in my Twitter mentions because I showed you a beta feature. But this we can use this today. Okay, fantastic. Let's go.
Yeah. So instead of using like, use rlike, and from there, this is going to be interpreted as a regex pattern rather than a wildcard pattern. So what we could do here is say I want. Let's say things that start with the letter 8 or the number 8, and then follow with, let's say, 7 through 9.
Yeah, I mean the one I can think of here, right, is that we also have the AWS region in here, so you could really easily be in a situation where you're like, oh, I want US East and I want US West. Oh, and then it turns out I want all the 2 region of APAC 2 or something, and then it's like, oh boy, I have to do a whole bunch of OR statements to get all those regions. This one is of course arbitrary, but yeah, like it makes sense if you know regex at all to be like, oh, you could just write a regex and look at all this like that.
That is beautiful.
So here now all of these numbers in here start with an 8, as we said, and then follow with 7, 8, or 9.
Yeah.
Now we have this restricted range of IP addresses that we're talking about without too much problem, without coming up with this exhaustive list. And we can do something more general here. So we could do something like this. So what is this saying? This is saying I want it to be 3 digits. So right now you can see these are 2 digits. I want any IP address that's in the range of 3 digits or more.
Yeah. Yeah, I really like that.
See, maybe we don't have any in the 3-digit range. Looks like we don't have any in the 3-digit range. So let's jump to the next number. So let's do 2 digits, dash. So now we're looking at anything that has 2 digits, then a dash, then 2 more digits, or 3 digits. So that's working out. So you'll notice that one thing, so the reason I did this example explicitly beyond the example we had before is because of this escaping here. and this is something that trips up a lot of people when first interacting with R-like, is the way that this is implemented is that this is first a NRQL string and is then a regex string.
Mm-hmm.
So this needs to be escaped like a string to then be interpreted like a regex. So anything that's escaped needs 2 slashes, not 1.
Right. Yeah. Yeah.
So
I mean,
in a normal regex, you'd find this, but you'll see it's not happy with that.
But of course, if you use regex a lot and sort of in kind of, interesting, unusual circumstances, if you're like, oh, like, let me just enter in this terminal command, but I'll store it as part of this JS that's going to run, and it'll have this regex, like this is pretty familiar, right? It's like double escaping, like it do come up, right? Like it'll happen to you many a time. So yeah, I think that I noticed it right away, but like, yeah, that makes sense.
Yeah, someone in the chat said this is super fantastic, and they manage hundreds of NRQL alert conditions. So yeah, super excited for the feature.
I do just want to make my
very useful for that type of situation. Absolutely.
Oh boy, chat just went nuts about adding regex to NRQL. Look at this. Okay, so people are happy about it. We're trying to query average CPU usage from UX Monitor stats and getting the y-axis in kilobytes megabytes converted to percentage, but the range is not getting fixed. Please suggest the attribute which can be useful here. Well, I'll tell you one. You can, if you add your query to a custom dashboard, there are settings available on that custom dashboard for the auto scaling of the y-axis. So that may be what you're getting, is that it's set to a particular y-axis. I don't know. I mean, I guess maybe we could go look at one. I don't know. We can fiddle with it a little bit. As far as the query, you know what? For that,
unfortunately, that's
John. I maybe would check in and we can take a look. But I'm sorry. Ashton's going to answer.
Well, I was going to say, I think there is possibly solutions, but unfortunately, I don't think it's in the NRQL that's going to fix that. That's going to be a UI solution thing.
Yeah, and Jules, who was on, demonstrated some ability to do that. I will say that you can do the basic like SQL math stuff. So if you want to like divide one value by another and get like a ratio, it usually auto scales pretty good. So Priya Mahajan, you might be able to that might be an effective solution. It sounds like maybe you did do that. Maybe you did convert it into a percentage by doing some query math. But yeah, that is like a UI thing. But I think that it totally can be done without going deep on like making a whole custom visualization.
Yeah. So now let's jump a little bit further into, this is going into the beta territory of features. So this is something that is not released yet, but should be on its way out hopefully soon. I know that people are very excited about it, and I'm very excited about it because it takes this feature of regex and expands upon it in a way that is extremely useful, which is taking this regex syntax and allowing you to extract values from strings to use them in different contexts. So as an arbitrary example again, let's continue looking at this IP address. Now, if I did something like this, if I did count star, so now I'm looking at the count of those hosts, and then say I facet on host. So now I'm getting, for each host that matches this regex, I'm getting the count of hosts that exists in that, or the number of transaction errors that exist for each one of those hosts, right? But this is not extremely easy to look at or as useful, because I'm trying to like kind of group these by this regex. So what if I want to say, I want to group them by this first digit? As it currently exists, there is no way to do this. If you facet on host, you're going to get all the hosts. You can't boil down those hosts to some inner grouping without doing something special. So what we can do here is do capture host and then have a regex here. Now this regex is going to have a little bit different syntax, and the syntax is potentially going to change, so I wouldn't focus on the syntax too much, more the functionality itself. But what if we, let's say, oh, I didn't mean to run that yet. Let's grab this. drop it here. And let's say we want to snag this one. So let's go here. So here's the syntax. So basically we're saying, I want to capture this regex string here. The syntax is this for, it's called a naming capture group or a named capture group. If you look up the RE2 syntax, that's the syntax we're using. And this is the syntax that's openly shown there and is supported by Google and everything. And then we're naming it bit. So we're taking this regex out, naming it bits, and this is the syntax to say to do that. Then let's run that. And now you can see the faceting is 8, 9, 2, 1, 3. So now you can see that apparently, by coincidence, there is way more errors on hosts that have an 8 as this bit. So this is being extracted, and the hosts that have 8 there is going to be a higher rate. I assume this is because there's just more of these hosts, and it's not actually to do with the fact that it's number 8.
Yeah.
But you can see how we can group by now this. So if we take this out and jump it up to here, now we're grouping by this whole IP range.
Yeah, so while we can't hit like y-axis scaling, we can very effectively say, hey, we need to cast this value right into something that is readable to other people. So instead of saying, hey, we're just going to group these and just show their raw IP address groupings or something, we can say, hey, we want to label this as follows.
Right. So, and this allows you to kind of generalize what you're working with a little more. So let's jump into another example.
Wait, before we go, I just want to clarify. So the capture, do we call it keyword or what do we call it? Action?
Function.
Function, yeah. Does the caption basically do in grouping by regex? Is that correct?
So I think the following examples might help more.
Mm-hmm.
All this does is take whatever this string is,
mm-hmm.
use this regex to pull the value out of whatever's being captured on, and then use that for wherever the context of it being. In this case, it's in a facet clause. So, if we have a host name where this range is 85,
mm-hmm.
then that's going to go into the group of facet for all the hosts that have 85 as the value that's pulled out there.
Yeah. So what we're going to get to is, let's think about an example where we have some host name, mm-hmm. and that host name includes like : memory allocation 12 kilobytes, 12 gigabytes, whatever, right?
Mm-hmm.
Well, that's just in the middle of a string that we're getting in, but it's important to us, and this is very big for like large enterprise customers, is maybe they're getting some parameter back, and what they really care about is in the middle of a string. And we would tell
mm-hmm.
them, oh, well, you can go and add some code to your, application code that will report that up to us as a metric that we can act on. But they say, well, I don't want to do that. I'm already reporting a string up to you, and somewhere in there is a number, is a value. And if we could just do a little math and just work on it a little bit, we could get to something interesting. And so what's in beta now is, sorry, Ash, I'm trying to set you up here.
Yeah, no worries. Yeah, absolutely. Yeah, exactly. So and this is particularly useful for like logs. So we have a new up and coming product that's been doing pretty well, logs. And the logs product is, of course, working with these massive strings. And generally, logs are roughly structured, but not super structured. And there's usually bits of information in the middle of those giant strings that are very useful. And we're going to look at an example like that right now. So if we do something, actually, I need to jump to a different account here.
By the way, also likes the just art that we've created with this chart, and I do too. I think we should print this out and put it on the wall or something, and make it into wallpaper. That like spiky, 30 or 40 different lines.
I can see like the new Relic office having art like that in the walls.
Yeah, I will say you heard it here first that there was some talk about what swag we were going to do for FutureStack, and my big ask is that we make enamel pins, of course, and what I want to make them based on is our various versions of DataViz, right? Like one from the Kubernetes cluster viewer, another one from the like hexagon viewer, and the lookout, and obviously the line plot as well.
Look up an area chart would be really cool too.
Yeah. Oh, that'd be a good one.
Cool. So looking at these logs, this is, I don't actually know if this field comes along with things that are in the default log product. This is just something I found that would be a useful example that seems to be somewhat consistent. Is container image. So this is the Docker image that's used on the container that these logs are being sent from. And you can see in these strings, you'll find the release number here at the end.
Oh, yeah. So let's say we wanted to say, hey, I want every release number greater than 5, right? And
right.
that just would, you'd have to write like some or statement that says or 8 or 9 or you know, even with regex right now. But capture takes us a little further. Yeah, I'm sorry, go ahead.
Even if we tried to do some or, there's different strings that come before that. Like this one is preface. So there's just no reasonable way to do it. You don't know what the comprehensive list of possible things are. And I just want to know the release numbers of everything. So
that is genius.
Right. So this value here is a useful value that is currently, I can't reach it. There's no good way to take advantage of this value in this string. So instead of that, we could do something like this. If we, as an example, just to show it directly, let's say capture, and then do something like, okay, so what is this regex here? So without going into too much about it, actually, I think this is the, is that the right? Yeah, okay. So this is basically saying anything can start with this, or anything at the beginning, appended with release dash, then we're going to capture any numbers that follow.
Yeah.
So this is just saying digit more than 1.
Yeah.
So let's capture that. And actually, I'm going to add an additional where clause here, just so we're talking about the correct stuff. So this is basically just narrowing it down to everything that has release in it. So let's run that. All right, so now we can see that in our selection, instead of having that massive string, now we have just the release number.
Nice.
That's so cool.
But here's the problem. This is still a string. So we're in the JSON chart type, and we can see this is still a string. So what we can do is wrap this in numeric. This is basically a cast to numeric type. Run that. And now we can see we're actually working with numbers now.
Ooh.
So now we can do something even cooler. We can take this and do histogram. And I know that these go really high. So we're going to say a ceiling of 3,000 and say like 50 buckets. Let's run that. And we're going to have to take this off of JSON view.
Let it fill this giant JSON first, and then
Yep. So now we can see the distribution of releases that exist.
Yeah.
Now, this is, again, a bit arbitrary still because these are different services. So these release numbers actually just don't correlate to each other really.
Some are sitting at 2,000. Right, we could add a where clause or something, right? If we want to consolidate.
Absolutely.
Yeah.
Yeah, but you can really start making interesting questions. This is an example of how you can extract a string value out and start getting interesting values from it.
Yeah.
So now we can do the same thing you were just asking about a moment ago, where you could say, still need to cast this to numeric. So now we're saying we only want to look at greater than 500. And this will work correctly as well. And we'll see that our chart has now been chopped at the bottom.
Yeah, it includes no old releases or whatever, low number releases, whatever that might mean.
Yep.
Again, so this one is in beta. Don't come for me on don't call me out on Hacker News if it's not released next week. Give us a year, and I know this will be out. So,
Yep, this is in beta, and there is again open questions about the syntax. So we possibly will be changing this to something else. A lot of things are up in the air about this, but the functionality itself is on its way to being attempted to be released. So yeah, this I think is going to be particularly useful for a lot of things. You will notice though that those queries were a lot slower, and that's because there's no way around it. Regex is expensive. It's more expensive than any other filter operation that we have. That is one of the things that we're currently investigating on performance to try to possibly figure out ways to improve it. Because this query was previously pretty quick, and now we're sitting down here at like 12 seconds to run it. So be tentative and cautious about using Regex. If you don't need to, use other features like the like clause or other features that can do, if you can find equivalent ways to use other features that are faster.
And yeah, I mean, for sure, try out New Relic Explorers, the discussion site, to like get some advice on your current NRQL, because very often if there's something you want to do that isn't this where sort of a piece of a datum that you really care about is buried in a string. If it isn't that, then check in on New Relic Explorers about the current NRQL tools instead of like putting pressure on this system. Because yeah, you know, we all hear the classic adage, right? It's like, you know, a developer wants to solve a problem. She just realizes, of course, she has to solve it with Regex, and now she has 2 problems. So, you know, don't dive in feet first. But yeah, you know, especially for string parsing, especially when it is something you know you're going to care about, totally worth looking into.
Yeah, absolutely. So speaking of advanced features, nice.
Oh, so good.
Yeah, that's right.
We're going to be now jumping into something that is on the deep end of advanced. This is a new feature that's come out that I'm still exploring on figuring out use cases for it. But I have found some very useful things for it. But it is, if it's not super clear to start with, that's fine. This is definitely the deep end of NRQL usage. But for those who are advanced users, this is definitely something that pushes the bounds on things that you can do that previously were absolutely impossible.
Yeah.
So,
all right, so black diamond slopes, everybody. Black diamond slopes. You will break a knee if you're out for the first time. But we're gonna have some fun. We're gonna dive a little deeper.
Yeah. So say we have something like transaction. Again, we're going to look at average duration.
And I'm actually going to step away from my camera for a moment because guess what? I actually do have a body. I don't need a doctor's note to prove it. So I will be back in just a minute. Please go on ahead, Ashton. I've seen this one yesterday, but yeah, I'll be right back with you.
Yep. Cool. So we have average duration here. Seen this, know what this looks like. But say I want to do facet, facet account. So now we're seeing the average duration of the accounts that are using this. And don't worry, these are not actual customer accounts. These are fake ones in staging. But let's let's do host name just to keep things easier. Okay, so these are hosts. These are the average duration of these hosts, top 10. But say we want to do like limit 100. So now we're looking at 100 hosts, our top 100 hosts for their average duration. So with this,
what do you mean by top? Like, how do you like what is it filtering by when you say limit 100?
Yeah, so that is quite the rabbit hole of a question. So without getting into too much detail, our backend system, NRDB, that supports this is a distributed system. And with that, coming up with the top is a bit of a complex question, because we are distributing this query to thousands of workers that are all individually have pieces of this data and are doing work on that piece. And if each one of those workers just tried to come up with their top 10 on their own, they'd all come up with different top 10s. So how do we solve that? Without going too much detail, facet queries, these queries that do faceting, which needs to have a top, actually do two queries. There's first a query that basically says, tell me, given this data set, what the top 10 are. And then once we have the top 10 agreed upon, then we execute this query specifically talking about those top 10 only. So we know what the top 10 is already before we start working on it.
Oh, that makes
In
a
this
lot of
case, the
sense.
top is based on the average. So we have some approximation that comes up with a very quick top 10 approximate for an average. Get the top 10 based on the average. So this, you can see this is descending 60 to some small value. We agree upon that top 10 or top 100 in this case, and then we execute the query across the cluster with that agreed upon top 100.
Wow, it's so cool to see like what goes on under the hood. That's awesome.
Yeah, it's pretty interesting stuff. Again, fasting is its own rabbit hole. There's a lot of caveats and a lot of things going on there that we're gonna just kind of hand wave for now. So this is the top 100, but this average value by host is a computed value. This is not something you can find in the data set. We have just calculated this value. What if we wanted the average of these values? So what if I wanted the average across these hosts? Well, right now, you can't really average this. The best option here is export these numbers into an Excel spreadsheet and then find the average yourself, which is really unfortunate. And you can come up with really interesting stuff, but you can't work on these values that you've come up with. That is not the case anymore. You can now do work on this itself. So we can do from this query. So previously we were doing from a transaction being the source of the data. Now we're doing from this query as the source of the data. Now if I can do select average. So now this piece here is referencing the result of this. So now we are getting the average across these hosts that were being aggregated in this inner query. So if we run this, the average is 5. So now we know the average duration across those hosts that we found in that top 100 is 5. So again, this is an advanced feature. There's a lot of ways you can dig into this. And I will show some more examples to maybe help guide this along. So one thing that might be confusing is what if I did average of this and then average of something else? Which average is this referencing at this point? So this is actually an ambiguity, so we need to name things. So in this case, we would do, say, as transaction duration. And then out here, we would reference it by its alias. And now this should be the same. So yeah. So if you do have ambiguity on, say, multiple function names, you can alias them to reference that alias instead. So yeah, let's dive into some other examples. What if we want to do this? Let's drop back to a regular query so we can see what we're doing. Let's do average duration time series. So we're back to the time series we saw early on. This is average duration through time. Now again, this is interesting. This time series is interesting. But what if I want the average of the time series? What if I want the average value of these buckets? Or maybe the percentile of these buckets? I can do that too. So we can do from out here, select percentile, average, then do like, I don't know, 50 and 99. So now this is saying what the average and 99th percentile of the time series buckets that existed in the previous query as a single result. Now again, this query is a bit arbitrary just to get the point across, but there's a lot of really interesting ways you can dig into your data by taking query results and aggregating around them further.
Yeah, pretty powerful.
And to the question in chat, this is out. This is GA. So this is not a beta feature. This is actually something you can use right now.
Awesome. I love that.
I love the query inception idea.
Yeah, it takes a bit of I've been continuing, even though like I helped develop this thing, I have still continued to need to think about places that I could use this, because my mind is not used to expanding the scope of queries to think how could I source this data for another query that wraps it to come up with even more interesting data. It's still something that I'm growing to become comfortable with and use in scenarios.
Yeah, I definitely think it's helpful to remember like that the purpose here is to reduce cardinality.
Yes.
Right.
Yep. Yeah, I was going to get to that in a second.
You could say, oh, well, that's a limitation, but really that's like, no, that's the purpose, right? Like that's the direction you should be going, is saying, hey, I'm looking at this time series, but it's not like I want either a total or I want an average. And that makes more sense to say, hey, I want to wrap my query.
Yeah. So yeah, it's good you call that out. So one thing that is really important for these types of queries is you always have to be going from higher cardinality data to lower cardinality data. If the cardinality is the same, then you're not actually doing anything. So for example, if we do average duration facet host, and then do, let's say, time series on that. So we have this data set here. This is the, maybe that's not a very interesting data set, because it looks like we probably have a deploy here that's making things weird. So let's just do facet host. So this is, again, average duration facet host. But if we wrap that and say from select average facet host. So now we're still faceting by host. So the cardinality is equal. Previously, we had an average per host. That was the cardinality, the cross product of host. And now we have that same cardinality. So this doesn't do anything. The average of this is a single data point. Each one of these averages is one data point. So the average is the same number. So what we'll find is this doesn't change the result at all.
Yeah. Yeah. So you want to be moving downwards in cardinality, right? To get, but yeah. So, when we, in rehearsal, when you said, oh, hey, this is a limitation, I was like, oh, yes, it makes sense. It would be a limitation. But actually, also, it's like, that's the feature, right? Like, if you're not doing that, you've just kind of lost the plot a little bit. If you're like trying to take the average and then have both like time and value and then average it again, like that's not making sense.
Right. So in this case, here's another query where we're faceting by host and account in the inner query, and then only faceting by host in the outer query. So again, it takes a bit to like grok what this means, but this is saying I want to see the average duration for each account on each host. And then I want to see what the average of those accounts duration is per host. So this is reducing cardinality. So now we're finding the average, and what's in here is per account. But we're keeping the cardinality of host. So if we do this, we'll see that across these hosts, the average, the highest average account duration per host is 11. Again, a contrived example, but shows that the result is now changed. This is now a different result than what you saw in the query where we didn't reduce cardinality.
Yeah, this is really neat. I mean, I want people to run and try this out. We linked to some advanced docs, and we'll do the same thing in the YouTube description if you're watching this on YouTube. Somebody just
one last thing before we jump too far. I will say that this is infinite depth. So you can do this as many layers as you want. So now we have this chart that goes from 11 to 5. We could just go another layer. We could say from this thing, now
it is literal query inception. I love it.
Yes. I need to select here. So now we're getting the average of these values. And again, this is meaningless at this point. This is just, diving in further than we need to. But just to drive the point home that if you continue to reduce cardinality, you can continue to dig in deeper. So this query does reduce cardinality because we were faceting by host. Now we're no longer faceting by host. So this is the average by host.
So you would need to have, now this may sound wrong. This is sort of how I think of like this from like my geometry work. It's like you would need to have something that starts as like a 3-dimensional data set, right? Like you need to have something that has, by time and size and duration or something, right? Yep. To have that be a meaningful thing you'd want to do. But yeah, it's reasonable enough to do. So the question that I was going to is sort of, how do I want people to get started? I kind of mentioned this at the top of the show, but I would encourage people, if you want to get your feet wet in this, just go to any chart and say, show me the query that produces this chart. And you'll get a really nice variety of queries, some very, very simple, some, having tons of lines and are really quite interesting. And so that's a really good place to just start exploring like what's possible. Because from there, and maybe you're hopping over to do it, Ashton, you can then hit, take me to the query builder. Let me mess with this chart and see the results.
Yeah, I can go take a look at that here in a second. One last thing I wanted to add about this that isn't super clear, is that since and until clauses need to be on the outside. So you cannot have different since and until clauses within here.
Right, yeah.
You can't say this is since an hour ago, but this is since 3 hours ago. Because again, logically, that makes no sense. The source data is between these 2 hours. And then from there, you're operating on the result of the previous query. So of course, the since and until is kind of locked into the outside and then works together throughout the nested aggregations.
I love it.
But just taking a quick example, if we add this to some fake dashboard.
Yeah, while we're making this widget, something that I found really helpful is whenever I have a graph or a visualization that is really complicated where I can't see what's going on, I think that's a really good place to start when you want to hack on NerdQL to simplify what's going on so you can actually get some insights out of it. Because some of my graphs and some of the dashboards I cannot understand anything that's happening. It's too chaotic. So this can definitely help simplify that to get some value out of your visualization.
Yeah. So if you are in a dashboard or anywhere in the NR1 UI, almost always, sometimes there are some caveats to this, but almost always you'll see these dots here on the visualization. And you can jump into this, do view query, and you can see the NRQL that backs that query. And if you'd like, you can open it a query builder. And now we are exactly where we were a moment ago, looking at that query. And you can edit this, you can tweak it, you can add it to a different dashboard, or whatever you want with it.
That is beautiful.
Yeah, so that's the overview of what I've got for you.
Yeah.
Slide by, R-like, capture, which is beta, and then nested aggregations.
Yeah. I love it. Yeah, I said, we might take half an hour, but then of course I interrupted you enough that we ended up taking up an hour for it. But this is really good stuff. Let me see if we have any final questions in chat. No, we're good. We're good. Hey, let's wrap it. Oh wait, see, I'm not gonna make fun of me this time, Allie. I know you're watching. One time, episode 3, I was like, all right, show's done. Stream over. No plugs, no rating anybody else. Just sort of closed it up. But big one is FutureStack is coming up. If you want to come to a conference to talk all about observability, talk about open source observability tools, observing microservices, and advanced New Relic techniques, do come check us out for FutureStack. Registration link will be in the YouTube description. We do the Nerd Log every Thursday. We have developers and product managers getting to talk about new changes. You can follow me at Serverless Mom on Twitter, Twitch, TikTok, and all the other good places, GitHub. Daniel, you want to say some plugs and talk about when the album's dropping?
Yeah, definitely. So FutureStack is happening, like Nika said, and we have some amazing talks and amazing demos and workshops lined up, especially the Relicans. So please come join us at FutureStack. And yeah, you can find me on Twitter at LearnWDaniel and on Twitch as well. And yeah, super excited. This was a lovely time.
Perfect. Ashton, you got a SoundCloud album coming out or something else you want to plug? You want people to follow you on the social, or do you prefer to be left alone?
I do not have too much for the social handles or whatever. I am attempting to spin those up to start trying to post tech blogs and stuff, but nothing right now.
No worries.
Yeah, thanks for having me. I'm always excited to talk about NRQL stuff. I'm always tinkering on NRQL and expanding upon the language features. So I'm sure I will have more to talk about some other time.
Yeah, let's have you back with a sort of a newbie to have you take them through like a first few NRQL queries.
Yeah, we kind of dove into the deep end this time.
Yeah, I love that because sure enough, our viewers, right, are people who use New Relic. So sure enough, about half of them are like already doing this, like are already doing advanced NRQL. So that's great. But yeah, let's make sure we get everybody in and using it.
Yeah, absolutely.
All right. Thank you so much for coming out, everybody. I think Mia's going to close us out. We'll probably raid someone else's channel, probably raid Aisha, who should be running right now. All right. I don't know anything about Ruby Galaxy. Maybe Daniel does.
Yeah, Ruby Galaxy is a meetup for Ruby enthusiasts. And I believe Rachel and Danny, who are part of the Relicans, are going to be talking about Ruby stuff. It's going to be really exciting.
Fantastic. All right, we're going to hit that raid and we'll be out.
Bye, everyone.
Bye, everybody.